Consider the initial value problem. Starting off, we want to rewrite the given equation in terms of second-order linear differential equation with the constant coefficient given to us in the first question, which we would then simplify and then have to solve the complementary function by solving the homogeneous equation. First, by finding r using the quadratic function. This would get us our complementary function here. Now we want to find the particular solution for the non-homogeneous equation part of our initial value problem, which would get us this. Well, which we could decide to be this, but then we would find the derivative, then the second derivative, then we would insert into our rewritten given equation in order to combine all like terms to equal to for a to be negative 150 over 148, with b being 25 over 148, which would give us our particular solution here. And to find our general solution, which is adding the complementary function with the particular solution, we would get this by adding both the equations we have. However, we're trying to find solve the initial value problem. So we would have to solve for C1 and C2 from our complementary function here, which would require the equation that we rewrote, that we then simplified, multiplied by the applied force, and replacing d squared by negative 36, and doing some algebra, including some factoring out more with d here. This would get us negative 25 over 148 times 6 cosine 6t minus sine 6t, which we then would insert back into this equation here for our general solution. To find C1 minus 25, find C1 as 75 over 74, and now we can find, and after using that, in order to then suss out what is C2, we can find our specific solution for this problem as this below.